here we have a piecewise function that is defined to be negative 2 e to the 2x minus 2 when x is less than or equal to 1, and it's x cubed minus 3x squared when x is greater than 1. We wish to start by finding all critical points of f of x. So to start with, we have to know the definition. What is a critical point of f of x? Well, this by definition is where when I differentiate this function, so when I look at f prime of x, where f prime of x is 0 or it's undefined when it does not exist. So let's start by differentiating so we can find f prime of x. We can do this in two parts. We can first do it when x is less than 1 and when x is greater than 1. So let's start by looking at when x is less than 1. Let's see what f prime of x is. And again, you might be asking, why am I writing less than 1 rather than less than or equal to 1? Well, that's because to figure out what's exactly happening when x is equal to 1, you actually have to look at the slope from the left and the slope from the right. So when I circle it, I mean you have to differentiate this, and you also have to differentiate this, and you have to compare the values at x equals to 1 to figure out what's actually happening at x equals to 1. So since we're only going to differentiate this, we should write x is less than 1, not less than or equal to 1. So when I differentiate this, f prime of x, so we have to use the chain rule. So we are going to let 2x minus 2 be our inside function. So think of this as something. So you have minus 2, and you're differentiating e to something, which gets you e to the same thing, e to something. And then by chain rule, I have to differentiate this and multiply by 2. So that's what's happening for x less than 1. Let's look at what's happening for x greater than 1. So I'm differentiating this. That's just power rule. You get f prime of x is 3x squared minus 6x. So let's go through the two cases. So we first want to check where is f prime of x 0. Well, let's go through one by one. When x is less than 1, we're looking at when negative 4 e to the 2x minus 2 is 0. But if you know the exponential function, e raised to anything is positive, because surely e raised to some positive number is positive. E raised to 0 power is 1. And when I raise e by like a negative number, this is the same as 1 over e squared. So that's still positive. So e to really anything is positive. So we know when I multiply that by negative 4, you're not going to get 0. So here when x is less than 1, you don't get anything. You don't get any critical points. When x is larger than 1, let's see if 3x squared minus 6x can be 0, and here you certainly can be 0. How you can figure this out? You can try factoring out. So when I factor out 3x, I get 3x times x minus 2. So that's telling you that x can be either 0 or 2. So we have found 0 and 2, but here's the key thing. We only care about things larger than 1 for 3x squared minus 6x being 0, right? Because we're differentiating this function. So everything we're doing here, when I'm differentiating this, setting it to 0, this only applies when I'm dealing with x larger than 1. So since we got this extraneous x being 0, which is not larger than 1, we should discard it. So 0 does not count. So the only critical point we're really finding so far is 2. So let's move on. Well, we also gotta check where f prime of x does not exist. So that's the second thing to check. F prime of x does not exist. Well, here, now let's see if this thing can be undefined or this thing can be undefined. Well, this is exponential, that's always defined. This is a polynomial, it's always defined. If you're dividing by something, so if you got something like a rational function, then maybe it can be undefined because you're dividing by 0 at some point. But we don't have anything like that. So here, when x is less than 1 or x is larger than 1, we don't get anything out of this. It's none. But what about x equals to 1? Here, this requires some analysis. So because when x is going to 1, you're going from this branch of the function, or of the derivative, to this derivative being 3x squared minus 6x. So when x is 1, as you're switching from this slope to this slope, you might have some inconsistency. If the slope from the left is not the same as slope from the right at x equals to 1, then f prime is undefined, and if f prime is undefined, you are a critical point. So let's actually check what's happening at x equals to 1. So the slope from the left at x equals to 1, let's start by checking this. So when I'm looking at the slope from the left, I'm looking at this thing. And as x is getting closer and closer to 1, the slope, the f prime of x, which is slope of f of x, is getting closer and closer to negative 2 e to the 0 times 2. E to the 0 power is 1. So slope from the left is negative 4. What about slope from the right at x equals to 1? Well, as x is getting closer and closer to 1 from the right, the slope is, you're looking at this polynomial, x is approaching 1. So when x is 1, we have 3 minus 6. So you're approaching slope of negative 3. So you see that the slope from the left and slope from the right are not the same. So here, these two are not the same. So that's telling us that at x equals to 1, f prime of x does not exist. So here f prime of x, so f prime of 1, I guess, does not exist. So that's telling us that x equals to 1 is a critical point. So in conclusion, our critical points are x equals to 1 and 2. So we have found these two.